Here we're looking at Chapter 0, Section 2. We're talking about lines in a plane. We're specifically looking at the real number line. So this will be the first video that describes the real number line. So this is the first video out of this particular section. To talk about the real numbers, the real number line, we have to first discuss all the different types of numbers or different number sets that we're used to seeing. So again, what number sets are you familiar with? Now, in past classes, you've probably blown this off and you said, you know what, I really don't care what these different number sets are called, or maybe you kind of remember, but I'll tell you, as you go further through math, it becomes more important. So the first one we're going to talk about are the natural numbers. And that's a bolded N, and they start at 1, and they continue on up. Think about that like your counting numbers. If you were to ask a child to count, they would naturally start at 1. And so 2 is an element of the natural numbers. 2 is an element of that set that you see over there. So is 7. But now, -4 is not an element. That's not part of that set of natural numbers. So if you're not used to that notation, now's a good time to make a note of it in your text or in your notepad or whatever. A bolded Z stands for the integers. Comes from the German Zahlen, which stands for number, I believe. So don't quote me on that, but go ahead and, if you're curious, go ahead and look it up. So these right here are the integers. That's the set of numbers that have those specific values. So clearly 7 is also, not only is it a natural number, but it's also an integer. 3.6, nope, that's not an integer. That's not in that set. So there's your natural numbers and your integers. Another set that you're used to seeing is the rational numbers, which we'll call Q. Now, rational numbers are any numbers that can be written as the ratio of two integers. So you think about them like fractions. Okay, anything that can be written as a fraction or in fraction form. So here I've got is anything that can be written as the ratio of two integers. So like 7/2 is a rational number, or let's say 2/3. That's part of the set of rational numbers. Okay, 7 again is part of the rational numbers, right? Because we could write it as 7/1. But square root of 2, that's not part of the rational numbers. You can't write square root of 2 as a fraction. So there's proofs on why you can't do that. It's actually fairly interesting. Okay. Irrational numbers. Well, there's a couple ways we can define irrational numbers. But I guess probably the best way to think about the irrational numbers, I was going to say numbers that can't be written as fractions, which is true. Okay, but we're going to say numbers that are not rational numbers, essentially. Okay, I mean, they're the numbers that you're used to seeing, like square root of 2 and pi and e. Those are irrational numbers. So if you take the rationals and you add them to the irrationals, because they're mutually exclusive sets, you put those guys together, you get what we call the real numbers. And so we try to take a look at the real numbers as a continuum. Okay, on a line here, and so here's maybe 0. That's called our origin. And let me grab a couple more points here just to show you. We might have pi 3.14, 15926, so on and so forth. That's located maybe there, and then we might have the number 5. Okay, it's clearly a real number. So anything that can be written as a real number goes on this line. Now, from our origin, if we move to the right, we consider those real numbers to be positive, and if we move to the left, we consider those numbers to be negative. So what else? Well, we can talk about moving one way or the other a distance between two real numbers. So let's say we've got a number, I don't know, -2 and another number 3. And I want to move from -2 to 3. Well, we'll call this guy x1 where we start, x2 is where we stop. And so if we take x2 minus x1, we end up with 3 minus a -2, which is 3 plus 2, or 5. So what that tells us is that we moved 5 units to the right from -2 to 3. So it's positive 5. Now if we want to go from 3 to -2, then we have to switch the order. So again, x2 minus x1, but x1 here, the starting point, is 3. So if we do the math out, we get -5. So that means that we've moved to the left. So if you get a negative value out when you do the subtraction, you're moving to the left. And if you get a positive value out, you're moving to the right.